speakers.
Yeah.
So since the main task is to identify two speakers, so if two persons have different voice quality features, so they can be used actually as a source of information.
Independently of the speech task, you mean?
Yes, independently
Okay.
of, yeah.
Okay. Thanks a lot, Abraham.
Okay, thank you.
I think for now we can move on to the next paper, which is called Blind Estimation of Room Acoustic Parameters and Speech Transmission Index using MTF-based CNNs. And I think Suradesh is here with us. The floor is yours. Could you please provide us with a short summary of your paper, and then we can open up the question and answer. We don't hear you.
Hello, test.
Yeah, now.
Okay. I apologize. Acoustic lab have technical problems. Okay, good afternoon, Dr. Kodachi, right? Hello, everyone. Honestly, I am delighted to share my research with all of you, and especially as our chairman. Your expertise is maybe close related to my research. In our research is about estimating room acoustic qualities and characteristics through variety of standard objective index. We call room acoustic parameters. In my research, we estimate reverberation time, early decay times, clarity index, speech transmission index, and center times. These are the interested room acoustic parameters that's used in architectural and acoustic field. These can indicate or use for predict speech intelligibility, clarity to speech or music, and perception to reverberation. The standard procedure to measure such acoustic parameters performs under specific conditions without people. But in realistic environment that we are usually use, people and many conditions might always change. This condition would make this acoustic parameter change. Instead of use the well-known, well-designed signal to stimulate to measure the room impulse response directly, we estimate those room acoustic parameters from the record reverberant speech signal in such a moment. In that information, that speech convolute with the room impulse response, then we use this information to estimate the room impulse response. How we can estimate the room impulse response from the reverberant speech? We model the room impulse response as a stochastic model. According to an exponential decay model, we call Schroeder's IR model. That needs one crucial parameter, that is reverberation times. Therefore, we make use of the relationship between the distortion ratio of the temporal amplitude envelope of those speech signal. The temporal envelope will distort the modulation corresponding to the amount of reverberation times. So with this relationship, we estimate reverberation time for 7 octave bands by using the convolution light CNN network to estimate reverberation time for 7-octave band. Then from this model, we can reconstruct the approximate room impulse response so that we can derive the interest room acoustic parameter from the room impulse response model that we estimate. Yes, that's all. That's summarize of my work.
Thanks very much. It was a very interesting paper to read. Are there any questions? If not, I can ask something.
Yes, welcome.
So my question is, I can see how estimating the T60, you can derive the STI index because of your approximation of
Yes.
the statistical Schroeder's model, and I can see how you can estimate, how you can approximate the MTFs and so on.
Yes.
But what I don't have an intuition about is how do you manage to estimate D50 and C80 when these parameters are not only specific to the room, but they
Yes.
are specific to the source microphone distance as well?
Yes. This,
so could you tell
yes.
us more about that?
Very nice question. These two parameters that we try to estimate in this research show not good result, since it's like you mentioned, it's not it has more configuration that affect these two parameters.
Okay.
Not only the reverberation time, because in the blind estimation it is difficult to fix the distance between the receiver and the source. We don't know the exact direction of the source, the sound source and the receiver. In my opinion, to improve this accuracy of these two parameters, I might use more than one microphone to calculate the direction or distance of the sound source and the receiver.
Yeah, I can see that can be helpful. Yeah, some extra knowledge you have to inject, I think, in there.
Yes,
to
yes.
be able to estimate this. Yeah.
Yes, currently we use only single receiver, so this is the limitation of this technique.
Okay, thanks a lot. Very interesting. I think the third author has showed up. Is that correct? So the next paper would be computational pronunciation analysis in sung utterances.
Yes, that's me.
Okay, hi.
Hello.
And we have Emir to give us a short summary, if you can, of the paper, and then we can open up the question and answer.
Sure. Well, in a few sentences, basically, here we tackle the problem for automatic lyrics transcription, which is actually speech recognition from singing data from sung utterances. And in particular, in this paper, we create a singing adapted pronunciation model to improve the performance of word recognition rates. And to find a singing adapted, or to develop a singing adapted pronunciation model, we apply a comparative analysis comparing how words are pronounced in sung forms and in speech forms. And we present a computational analysis based on this, and through some statistical outcomes of this analysis, we create a pronunciation dictionary to be used in the LF-MMI speech recognition framework. And we found out that Although there's a marginal improvement, in singing, vowels are usually interchanged. Vowel phonemes are interchanged with each other. Fricatives are usually omitted if they are located by the end of the words and followed by a word that starts with a vowel. And yeah, that's it. Those were the findings that we found in the pronunciation differences between singing and speech. However, you know, although these observations were not very conclusive, I have to say, I mean, there could be more differences that we can reveal. We need more data for that because the analysis data that we used was less than an hour. And through our results, we show that